Hey everyone, welcome back to the channel. If you're new here, don't forget to hit that subscribe button and ring the bell for more AI and NLP content. Today, we're diving deep into something absolutely fundamental in natural language processing, the 4 stages that help computers understand human language. We're talking about lexical, syntactic, semantic, and pragmatic analysis. Think about it. When you read a sentence, your brain processes it instantly. But for a computer, it needs to go through multiple stages. By the end of this video, you'll understand exactly how AI systems break down and understand language just like we do. Before we dive into each stage, let's get the big picture. Natural language processing uses 4 hierarchical layers of analysis. First, lexical analysis breaks down raw text into tokens. Think of it as chopping up sentences into digestible pieces. Then, syntactic analysis checks if those pieces follow grammar rules, like a grammar teacher checking your homework. Next, semantic analysis ensures the sentence actually makes logical sense, because colorless green ideas might be grammatically correct, but semantically nonsense. Finally, pragmatic analysis understands the real-world context and intent. Like knowing, can you pass the salt, isn't really asking about your physical ability. Each layer builds on the previous one, creating a complete understanding of language. Let's break down each stage with examples and code. All right, let's start with stage 1, lexical analysis. This is where everything begins. Lexical analysis is like taking a paragraph and breaking it down into its atomic components, words, punctuation, even individual characters when needed. The main tasks here are tokenization, splitting text into words, morphological analysis, finding word roots and affixes, and normalization, cleaning up the text by lowercasing and removing unnecessary punctuation. Let me show you a simple example. Say we have this text. Learning NLP is amazing. The lexical analyzer breaks this into tokens. Learning NLP is amazing, and even that exclamation mark gets its own token. Now let's see this in action with actual Python code. I'm using NLTK, one of the most popular NLP libraries. First, we import the word tokenizer and sentence tokenizer. Then, we feed in our text. The word tokenize function splits everything into individual tokens, while sent tokenize breaks it into sentences. See how it handles punctuation? The exclamation mark is a separate token. This granular breakdown is crucial because different tokens might need different processing later. But lexical analysis doesn't stop at tokenization. We also have lemmatization, converting words to their root form. Running becomes run. Better becomes good. This helps NLP systems understand that different forms of a word are essentially the same concept. Why does this matter? Well, imagine building a search engine. If someone searches for running shoes, you want to show results for run shoes and runner shoes too. Lemmatization makes that possible. Moving on to stage 2, syntactic analysis, also called parsing. This is where we check if our sentence follows grammar rules. Think of it as the grammar police of NLP. Syntactic analysis builds a parse tree or dependency graph. It identifies parts of speech, nouns, verbs, adjectives, and shows how they relate to each other in the sentence structure. Let's look at a classic example. The cat sat on the mat. The syntactic parser identifies the cat as the subject, a noun phrase, sat as the main verb, and on the mat as a prepositional phrase describing where the action happened. Now compare this to mat the sat on cat. Even though these are the same words, syntactic analysis would flag this as incorrect because the word order violates English grammar rules. Let's see this in Python using spaCy, which has excellent syntactic parsing capabilities. We load the English language model, process our sentence, and then extract the dependencies. Each token has a part of speech tag and a dependency relation. Notice how cat is marked as in subj, nominal subject, and mat is POJ, object of preposition. This tree structure is exactly how computers understand sentence grammar. This is super important for applications like grammar checkers, machine translation, and even voice assistants that need to understand command structure. Now we're getting into stage 3, semantic analysis. This is where things get really interesting. Semantic analysis is all about meaning. Just because a sentence is grammatically correct doesn't mean it makes sense, right? The key tasks here are word sense disambiguation, figuring out which meaning of a word applies, combining meanings in context, and detecting semantic anomalies, statements that are logically nonsensical. Classic example, hot ice cream. Grammatically, perfect. 2 words, proper structure. Semantically, nonsense. Ice cream by definition is cold. This is a semantic error that syntactic analysis would completely miss. Here's another challenge, the word bank. Does it mean a financial institution or the edge of a river? In I went to the bank to deposit money, clearly financial. In we sat by the riverbank, clearly geographical. Semantic analysis uses context to disambiguate. Let's look at word sense disambiguation in code. I'm using the WordNet lexical database through NLTK. For the word bank, WordNet gives us multiple synonym sets. Each represents a different meaning. The first is about financial institutions, another about river edges, and so on. Semantic analysis algorithms would look at surrounding words to determine which synset applies. Words like money, account, deposit would trigger the financial meaning. This is crucial for search engines, question answering systems, and any AI that needs to truly understand what text means, not just what words it contains. Finally, we reach stage 4, pragmatic analysis. This is the most sophisticated level. Pragmatic analysis goes beyond literal meaning. It understands intent, context, sarcasm, idioms, and real-world knowledge. The key here is interpreting what someone really means, not just what they literally said. It handles figurative language, cultural context, and situational awareness. Perfect example. Can you pass the salt? Literally, this is asking about your ability to pass salt, but pragmatically, it's a polite request. Nobody expects you to answer, yes, I am physically capable of passing salt. You just pass it. Or consider, I'm falling for you. Syntactic analysis, subject, I, verb, falling, preposition, for, object, you. Semantic analysis, person falling in direction of another person. Pragmatic analysis, this person is expressing romantic feelings. Big difference, right? Pragmatic analysis is harder to code explicitly, but modern transformer models like BERT excel at this. Let me show you sentiment analysis as one aspect of pragmatics. Using the transformers library, we can detect sentiment and emotion, which are pragmatic features. This pre-trained model can identify whether text expresses positive or negative feelings. See how this movie was terrible gets negative sentiment? But this movie was terribly good might confuse simpler systems. Pragmatic analysis understands the overall intent. This is essential for chatbots, customer service AI, virtual assistants like Alexa or Siri, and any system that needs to respond naturally to human communication. Now, let's see how all 4 stages work together on a real sentence. We'll analyze, the bank can refuse to loan money if you don't have good credit. Stage 1, lexical. Break into tokens. The, bank, can, refuse, to, loan, money, if, you, don't, have, good, credit. Stage 2, syntactic. The bank is the subject, can refuse is the verb phrase, to loan money is the infinitive phrase, showing what's being refused. Stage 3, semantic. Bank means financial institution, not riverbank, because of context words like loan, money, credit. The sentence makes logical sense. Stage 4, pragmatic. This is explaining a banking policy. The intent is informative, not a direct refusal. It's describing a conditional situation. Here's complete code that runs all 4 stages using modern NLP libraries. This is a simplified pipeline, but it shows the flow. Each stage feeds into the next. The output from lexical analysis becomes input for syntactic. Syntactic structure helps semantic analysis, and all of it supports pragmatic understanding. Let's wrap this up. We've covered the 4 foundational stages of NLP analysis. Lexical analysis breaks text into tokens. Syntactic analysis validates grammar and structure. Semantic analysis ensures logical meaning, and pragmatic analysis understands real-world context and intent. Together, these stages allow AI systems to progress from basic word recognition to true language understanding. This powers everything from search engines to chatbots to machine translation. Which stage did you find most interesting? Drop a comment below. And if you want me to do a deep dive into any specific technique, maybe transformer models or sentiment analysis, let me know. If you found this helpful, smash that like button, subscribe if you haven't already, and turn on notifications so you don't miss future videos. Thanks for watching, and I'll see you in the next one.